Welcome back, guys. This is the second video going over the study guide. So we left off with the second page. Let's go ahead and take a look at the second page in the study guide. Find the inverse. So to find the inverse, we had a few steps. The first step that we would do is we would switch the x and the y's, and then we would solve for the new y. Okay, so that's what I'm doing here in the number 11. I replace the f of x with a y, and then right here at this step, this is where I switch the x's and the y's, and then I solve for the new y. Okay, so I went ahead and multiplied by 4. I subtracted 20, and then I divided by 3, and I got 4x minus 20 over 3. That's the inverse of the apparent function, or the original function. And we could split this into two parts, but since it doesn't reduce, I like to leave it like this. If it does reduce, then I do reduce it. However, if you forget to reduce it, I will not count off on the test. Number 12, same thing. Replace the f of x with the y, switch the x and the y's, and then solve for the new y. Get that y by itself. I got y is equal to x plus 4 over 2. Now, since that did reduce a little bit, I went ahead and divided each term in the top by 2, splitting it up, giving me 1/2 x plus 2 is equal to y. But do notice I said either would be okay. Alright, number 13, same thing. So, go ahead and replace the g of x with the y. Switch the x and the y, and then solve for the new one. This one's very similar to the one from the homework that we would do from that section when we talked about inverses. So there's quite a few there if you need more practice. But what happens is once you get the x and the y switched right here, go ahead and move that single 1 to the other side, and then right here you're going to multiply by y minus 1 to both sides. Now, a common mistake is some students will distribute. Notice I did not distribute, I just multiplied by y minus 1 to both sides, which eliminates it on the right and moves it to the top on the left. But then from here, I divided both sides by this x minus 1. So divide this side by x minus 1 and it cancels out. Divide 2 by x minus 1 and it turns into 2 over x minus 1. So don't distribute. Go ahead and just divide by the other parenthesis, and then your final step will be to add that whatever's with that y, move it to the other side. Okay, so I got it all the way down to here, and then like what we always do is we replace the y with an f of -1, which is the symbol for inverse. Okay, number 14 is the same, but you will see that the letters aren't matching up, so they have an h of n this time. If you want to just put an x, that's fine, and then replace it with an n at the end. But really, we can use any letter for our variable, right? So I know that my input is n, so I'm going to go ahead and just start by writing the problem with an n, and then replacing the h of n with a y, and then I switch them. So my n is now over here, my y is over there. Okay, and then now I'm going to solve for the new y, just like all the other problems that we've done with these inverses. Alright, so this one's very similar to 13. I multiplied by y plus 1 to both sides. Okay, so if you multiply by y plus 1 to both sides, I guess I did that after moving the 3. So I added 3 first, and then I multiplied by y plus 1, and that's how I got here. Remember not to distribute, okay? Go ahead and divide by the other parenthesis. Okay, and that's how I got to this step right up here. So -2 divided by n plus 3 is equal to y plus 1, and then you can just subtract the 1 to the other side. Alright, so you're going to have at least 2 on the test where you have to find the inverse, so just be ready for those. Okay, you're going to have 1 graphing a square root, so here's 2 practice problems. When you do graph the square root, make sure you're able to identify what's happening to it, and then also what the domain and range is. Alright, so This 4 out in front, that's going to make a vertical stretch. So I put a little note here and said vertical stretch. This -2 on the inside is going to shift it to the right 2. And this -1 is going to shift it down 1. So I started by going over 2, down 1, and plotting that point. And then since I know that it's stretching by 4, the parent function normally just goes over and up 1. But if it's stretching by 4, it's going to go over and up 4. It's multiplying that second point by 4. All right, you could test points and plug them in, and that's what I did with this table. If you're wondering why I skipped some numbers, remember you always start with the first domain. Okay, so looking at the original function, I know that with a square root function, whatever's underneath the square root cannot be negative. So I took x minus 2 and said that's going to have to be greater than or equal to 0, meaning it's positive. I moved the 2 to the other side, and I got x is greater than or equal to 2. So that's where I'm getting this domain value down here. I did show the other notation. So here's the other notation. Both of those would work for stating the domain. And then that's why I started with 2, as I was saying. I started with 2 because that's the first domain value. And then I went ahead and plugged 3 in because that was a nice spot. And then all these numbers in between were not, they were all going to be decimals. So I just moved over to the next nice number, which was a 6. If you were wondering how I knew that, looking at the square root problem, I was thinking, well, what's another number I can take the square root of? And if I take the square root of 4, that's going to give me a nice number as an output. So I was thinking, what's going to make this square root be a 4? Well, that's when x is 6. So that was the process that I took to find those points. If you don't like that, you can just keep plugging points in. I did not say to make a table here. So if I don't say to make a table, technically you don't have to make a table, but we use the table to help us make accurate points. So if you, on the test, don't make a table and you only graph this point and then you just do that, you're going to miss points. Okay? You need it to be more pretty precise to the first point, maybe the second point potentially. Okay? So do your best sketch of it. Go ahead and get some points to make good locations. Don't just plot the first point and say, oh, I think that's what it's going to look like. Because if you do that, you will be counted off. All right. And then for the range of the problem, I typically do that at the end. So after I've graphed it, the lowest point is at -1. And this function goes to infinity. So it's from it's all numbers above -1. And I have both notations for that. Okay? All right, let's move on to the next one. Y is equal to -3/4 square root of x minus 1 plus 4. So the first thing I notice is the negative sign. That's going to reflect it. The next thing that I notice is this 3/4 is going to compress it. Remember, whenever you multiply by something less than 1, or a number in between 1 and 0, I should say, that's going to do a vertical compression. If you're wondering what does compression mean, it's the opposite of stretching. It's just kind of smushing it down. All right. The -1 here is going to move it right 1, and then the +4 is up 4. So with that information, I went right 1, up 4, and that's where I plotted my first point. And then to get the next point, typically you would go over and then up 1, right? That's what the normal function does for a square root. But I have a negative, so it reflects it down, and then the multiplier of 3/4 is going to make it go down just 3/4 instead of 1 full unit. And that's how I got that next point. But once again, you can plug numbers in, and you don't really have to remember all those steps as long as you know how to evaluate the square root and plug numbers in. So what I mean by that is when you plug 1 in, you get an output of 4. When you plug 2 in, you get an output of 3.25. When you plug 4 in, you're going to get a weird decimal, so I skipped it. I skipped 3 as well. I went over and went to 5 because that was another decently nice, not irrational number. It was a rational number. So I went and plugged the 5 and got 2.5. All right. Okay, domain for this problem. So the lowest x value is 1, and it goes to infinity. So I said all numbers greater than 1. Remember, though, what you're doing for domain is you're taking what's underneath, and you're setting it greater than or equal to 0. Okay, so don't forget that step. That's what I'm doing to find the domain. And then for the range, I noticed that the highest point's 4, and it's all numbers less than that. So that's what this range represents. Okay, there's page 2. Thanks for watching. Go ahead and switch over to page 3 video.